Okay, my friends, we are going to be working on factoring polynomials. So this section is a factor a monomial from a polynomial. And if you don't understand my fancy definitions, not definitions, but vocabulary on what a polynomial, monomial, binomial, and trinomials are, you can check out the video on what's a polynomial. So let's just jump right in. The thing about factoring is the more you do, the better you get at it. It's almost like driving. You got to jump in the car. Well, of course, get your license. But you're not an expert driver until you actually start to drive. That's when you get better. That's why stop honking people if you see that maybe they're not perfect on the road. Maybe they're new drivers. What? You just jump in a car and became an expert? Okay, I had to get that off my chest. Thank you. Let's jump in. So here we go. So we want to factor a monomial from a polynomial. So here we have a polynomial. We have 16x cubed plus 32x squared. So they're actually looking for a factor because it's going to be a factor. It's going to be a monomial from these two terms, this polynomial. So how you factor, basically, factoring is actually converting. I would like to say, simply putting it, factoring is converting terms into factors, right? I'm not I didn't see that definition anyway, but I won't be surprised if that's not new. But if we want to actually looking for a definition of factoring, think of converting terms into factors. Now remember what we said earlier in my lesson with you is that I differentiated the difference between a factor and a term. And I always stress that. Remember, factors are multiples, right? And we also identified with the operation of multiplication and division, right? And, so they're usually constants or a combination of constants and variables. And terms are a combination of constants or variables, or you could even say factors that are separated by addition, factors separated by the operation of addition or subtraction. Okay, so whenever you're adding or subtracting constants, variables, or a combination of both, these are considered terms. But if you are multiplying them, right, these are considered factors, right? So once you take factors, or as the book had put it when we define polynomials, if you take monomials and you add them, right? You separate them by addition or subtraction, which means you're going to perform an operation of addition or subtraction. You're working on terms. Now, when they give you a group of terms and then they ask you to factor it, right? The concept of factoring is converting terms into factors, because you're going to see that these two terms is going to become one factor. And we do so by finding a GCF, the greatest common factor. So the reason why they said the greatest common factor is if we look at 16 and 32, they both have factors of 2. They also have factors of 4. They also have factors of 8. But also they have factors in common of 16. So what is the greatest common factor these two terms have? And that is 16, right? So 16 is the greatest common factor between 16x cubed and 32x squared. But it's the greatest common constant factor. Remember, a constant is any number. Constant is any number, right? And a variable is any letter or symbol that represents a number. All right? So the constant factor is not the only thing this expression has in common, right? So let's start by taking out the first common factor. So the first common factor is 16, and let's look for the other common factor. Now they both have a factor of x. And why is x a factor? It's because 16x cubed is the same as saying 16 times x cubed. And remember, factors are multiples, right? So if we look at the x cubed and the x squared, x cubed and the factors x squared, right? And we expand both of them, right? Here we have 3 factors of x and here we have 2 factors of x. What's the greatest factor they have in common? Remember, it has to match. Now they both have x in common, right? Both of them have x in common, but it's not the greatest. It's the least, actually, right? Not to be confused with least common multiple. So if we look at it here, they have another x in common. They have x squared in common, right? But do they have x cubed in common? Nope. Only x cubed has an extra x, but x squared does not. So the greatest common factor for the variables is x squared. So my monomial that I'll be pulling out from this polynomial is actually 16x squared. Here's another way you can find it when you're looking for the GCF of any variable. For the GCF, let me make a note of that. Just a hint. For the GCF of any variable factors, right? Take the lowest power between the factors, right? So for example, if I ask you to find the greatest common factor between x fourth plus x cubed plus x squared, right? The common factor between the GCF, the greatest common factor between these 3 terms would be x squared. Take the lowest power. Even though it sounds contradictory from greatest to lowest, you're thinking of it too literally. You have to think about it mathematically. Mathematically, x squared is the greatest common. Common means it's common in all of them between these 3 terms, right? It's not the highest power of the terms between the 3 terms. It's the greatest common. So here we have 4 factors of x. Here we have 3 factors of x. And here we have 2 factors of x. But we can see that the only thing they have at the same time that can be found simultaneously is 2 factors of x. So the GCF for this expression would be x squared. So that's what I'm saying. When it comes to finding the GCF for any variable factor, hint, take the lowest power between the factors. Okay? So here we see that our GCF, as I explained earlier, was 16x squared because the greatest common factor between 16 and 32 was 16, because we see that 2, 4, 8, and 16 were all common factors, but it wasn't the greatest. And the greatest common factor between the variables is x squared, as I explained earlier. So what is left? What factors are left over? So how you find the factors that are left over is that you take your monomial that you factored out and you divide it by the original expression. So if I divided 16x cubed by 16x squared, the constant factor cancel each other, and the powers, if you subtract, you will get 1 factor of x remaining, plus 16 into 32 is 2, and x squared divided by x squared is x2 minus 2, which is x to the 0, which cancels out. I proved that theory time and time again. So the x squared factor cancels out and we only have a remaining factor of 2. So here we have the monomial from the polynomial. So here we go again. Here we have these 2 terms When we factored it, which is a process of factoring, we end up with factors, because you cannot call x 16x squared times x plus 2. You can't call them terms anymore. This is actually one. Ooh, guys, apologies. That is my anxious 1-year-old trying to learn math. Goodness, guys, my humblest apologies. I don't want to do this video over. It takes a lot of energy. But as I was explaining, the concept of factoring is converting terms into factors, and that's exactly what we did here. And my son completely threw me off. Let me do one more. Let me do one more problem. Here we go. Here we have another one. So here we have 9a cubed minus 3a squared plus 6a. All right. And if we look at all the constants, we're going to look for the GCF. We're going to make, factor this expression. If we look at all the constants, we see that the greatest common factor they all have in common, we can all find a common factor of 3, right? And if we look at the variable, because we learn of our shortcut technique, we don't have to sweat it. We know we'll take the variable with the lowest power. So that's 3a. And what do we have remaining in our factor form? What factors do we have left over? We will divide our GCF into the original expression. And let's see what we have. 3 divide 9 is 3. 3a3 minus a1 is a2. Minus the 3 cancel. a1 minus a2 minus a1 is a. Plus 3 divide 6 is 2, and a cancels. And that's our monomial factored from our polynomial. All right. And this is one of the first steps in factoring. Again, my humblest apologies. I know this is public, but I know I feel safe with my students. Safe zone. You all know what safe zone means.